Hi guys, Mr. Kerwin here, giving you a nice little overview of 7.1 through 7.6 before your quiz. This chapter is about ionic and metallic bonding, and the first half is largely about ionic bonding. You might remember from the last chapter we talked about valence electrons. They are the electrons in the highest energy level. They are the ones that interact in bonding. So each group, each column in the periodic table has the same number. So for example, calcium's in group 2. It's in the second row, so it has 2 valence electrons. If you go to the other side, it works also. Carbon is in group 4 or 14, depending on which periodic table you're looking at. So it has 4 electrons. Fluorine has 7. Helium is kind of the one exception. In most periodic tables, you will see it on the right side of the periodic table, but it only has 2, even though it's with the noble gases. So let's talk about dot structures for a moment. That's something you might want to get familiar with as we get further into the chapter. It's fairly easy, and it demonstrates how the valence electrons react in bonding. So dot diagrams, you might see dot structures, dot diagrams, Lewis dot, they're all the same thing. So what they are is that they are little diagrams that show you how many electrons you have in each element, in each atom. So here is kind of a very basic one of the representative elements. Your first 2 columns, as you can see, 1 there, 2 there, 3 and 13, 4 and 14, like I mentioned, look at those 4 in carbon, all the way to 7 in fluorine and 8 in neon. Do you have to memorize this? I would know that this is how you find the number of dots, and this is how the dots would look in a Lewis dot structure for these elements. The octet rule is covered in 7.3. Now, Lewis dot structures allow us to see which elements will bond because the octet rule. All these elements are trying to bond together so that they have 8 electrons each. The octet rule simply means that most compounds will form with a stable 8 in their outer shell. Think of the dot structure as a lunch table. You've got 2 seats at the top, 2 at the side, 2 at the bottom, and 2 on the other side. If the octet is full, you can't sit with us. That's a little joke I used to tell my chemistry kids. So you're trying to fill up that full octet. The noble gases on the right-hand side have a full octet already, so they don't usually bond at all. The metals on the left-hand side usually have 1 or 2. They usually give up their electrons to form a compound with a non-metal to form a perfect 8. Non-metals will take those electrons from the metals. We'll cover that more in the next video. This might be a review, but let's talk about ions. An atom or a group of atoms with a charge is called an ion. A positively charged ion is a cation. A negatively charged ion is an anion. The way I remember this is cation, so it's cation, where the T, positive, is like its whiskers. If a neutral atom loses an electron, it becomes a cation. So for example, if I had sodium and sodium loses an electron, it becomes a positive ion or a cation. The opposite, an means opposite. Anion is when a neutral atom gains an electron, so charge. So in this example, chlorine gains an electron, so it becomes an anion. We usually refer to cations as the name and ion, whereas nonmetals we usually call them the name with "ide" at the end. So bromine becomes bromide ion, oxygen becomes oxide ion, and so on and so forth. Your cation charges are very similar to how you find the valence electrons. Group 1 metals are +1, group 2 is +2. Go on to the other side, your group 13 metals are +3. Not all metal ions are predictable. Tin and lead form +2 and +4. Most transition metals are +2 or +4. I would just try to know a couple of those in case you were asked that on a quiz. On your anions, back to the other side, 18, your noble gases, you can't sit with us. They don't gain or lose electrons. Group 17, gain an electron. Group 16, gain 2 electrons. Group 15, gain 3 electrons. And backwards. This is similar to a table that your teacher should have given you. Do you have to memorize this? No. But just notice the trends. 17 here has -1, -2, -3, 1, 2, 3. Notice those patterns and remember those. Ionic bonding consists of combining cations and anions. This happens because of electricity, right? You have a negative charge and a positive charge, and they are going to attract each other. That is simply how ionic bonding works. It's quite simple. Most ionic compounds contain a metal and a non-metal. As you know, most metals have a positive charge, most non-metals have a negative charge, so they attract. You'll write the name of the compound by giving the name of the cation, then the name of the anion. So sodium chloride is the classic example. Now, the strength of the bond depends on the charge. You were asked this in your exercise, so make sure you know that as well. A +2 charge is stronger than a +1 charge. And that's it for today. I hope that wasn't too rushed, but I wanted to make sure I got this all in before my 7th period. If you have any questions, feel free to see me after school or ask me during class. Have a good day.